Welcome to this video on the topic of Year 8 Mathematics, expanding brackets. In this lesson you'll learn how to expand algebraic expressions containing brackets. Brackets may be used to represent multiplication. The product outside the bracket multiplies with the expression inside the bracket by multiplying with each term inside the bracket. Consider A multiplied with B plus C. What this means is that the product A over here is going to multiply with each term within the expression B plus C. So that means A is going to multiply with B, and then it's going to multiply again with C. We can show this by drawing arrows underneath. A multiplies with B, A multiplies with C. So the expansion of this is going to be A times B plus A times C. Let's have a look at how we can put this theory over here to use. Consider we have simplify the following algebraic expressions: 3x plus 1. We want to simplify this out by completing the multiplication. To do this, what we need to do is we need to multiply the product on the outside with each term on the inside. So 3 is going to multiply with the x, and it's also going to multiply with the 1. This expansion is going to look like 3 in brackets x plus 3 in brackets 1. Completing this, we get 3 x's plus 3 1's, which is just 3. So therefore, our expansion is 3x plus 3. Okay, next one, B. 2 multiplied with 3a minus 5b. Again, we expand this out. The product of 2 is going to copy itself onto 3a as well as copy itself onto the negative 5b. Remember, the negative belongs to the 5. The expansion of this is going to be 2 in brackets 3a plus 2 in brackets minus 5b. Expanding this out, 2 by 3a is going to be 2 times 3a, which is the same as saying 2 3a plus 2 minus 5b. Finishing this off, 2 3s are 6, plus 2 by minus 5 is negative 10b, and therefore we get our completed answer. If you like, you can get rid of the plus symbol and just have the negative there, or if you don't like it, you can keep it like that. Either answer is fine. Okay, let's look at something a little bit more complicated. Example 2. Simplify the following. We have minus 5, then in brackets 3 minus 2u. What we're going to do is we're going to expand this out. Remember, the expansion works by the product outside the bracket multiplies with each term inside the bracket. So that's going to be negative 5 is going to multiply with the 3 plus the negative 5 is going to multiply with the negative 2u. Moving along, minus 5 times 3 is negative 15. Plus, and then this one, I'm going to choose to just go straight for the expansion here. Minus 5 times minus 2 is double negative 10, which is the same as saying positive, I only need one plus symbol. So it's 10u. Therefore, my result for this is minus 15 plus 10u. Again, let's multiply this out. I have minus 3x in brackets minus 4x, take 2u. We expand this out by the product outside multiplies with each term inside. We're going to get minus 3x outside, minus 4x inside, another copy of minus 3x outside, minus 2y inside. Expanding this out, 3 4s are 12, they're both negative, so that's going to make a positive. We have x, and we have x. 3 2s are going to be 6. Remember, they're both negative, so they're positive. We're going to have x, and we're going to have y. Finishing this off, I have 2 x's, so I'm going to get 12x squared plus 6xy. Okay, next degree of difficulty, something that looks a bit odd. We have, in brackets, 5x plus 2y. Notice that we don't really have anything outside the bracket, but what that means is there's an implied 1. The 1 is going to imprint itself on the 5x and the 2y. Thus, the expansion is going to be 1 5x plus 1 2y. Hence, the expansion is just 5x plus 2y. Now the rule for this is simply, if there is no product, just get rid of the brackets. Okie dokie, next one. We have a negative outside the bracket, and then inside we have minus 2a plus 3b. Now again, this one's a little bit confusing. It's just a negative out front. How do we deal with that? Well, if there's just a rogue negative, between the bracket and the negative we have an implied 1. So if we go for the expansion here, we're going to get minus 1 imprinting itself on both the negative 2a and the 3b. This is going to expand out to minus 1 times minus 2 is just 2, plus minus 1 times 3 is 3b. So the takeaway here is that when we have a negative outside the bracket, everything gets multiplied by minus 1. When there is nothing outside the bracket, you can just drop the brackets altogether. Alright, something a little bit trickier. We have negative 6b cubed f cubed, then in brackets minus 4b squared minus 6f squared. We deal with this by getting our product outside and multiplying it with each term inside the bracket. Again, remember the negatives belong to the coefficients. This expansion is going to be minus 6b cubed f cubed in brackets minus 4b squared plus negative 6b cubed f cubed in brackets minus 6f squared. Multiplying the coefficients, 6 4s are going to be 24, they're both negative so it stays positive. We have b cubed, b squared, f cubed. Plus negative, 6 6s are 36 so that's going to flip to positive. Then we're going to get b cubed, f squared. Fixing up the exponents, we have 24, b to the power of 5, f to the power of 3, plus 36, b cubed, f to the power of 5. So something that looks quite difficult turns out to be quite simple, so long as you follow the basic steps. Okay, one more. We wish to simplify minus 6c squared d squared in brackets 11d squared plus 10. Let's have a go. Remember, the product outside imprints upon both the terms inside. Minus 6 11s are negative 66. C squared, d squared, d squared. Negative 6, c squared, Then we're going to have minus 6 times 10, which is negative 60, c squared, d squared. Simplifying this out, the two d squareds will become d to the power of 4 minus 10 c squared d squared. Hence we find our simplified version to be negative 66 c squared d to the power of 4 minus 10 c squared d squared. Extension. Expanding double brackets. What we want to do is we want to simplify expressions where there are two brackets and each bracket contains an expression that has multiple terms. So for a over here it's b plus 6 and then c plus 8. Now this can be done using the same method above but in a slightly more long-winded manner. Start off by writing out my expression, then what I'm going to do is I'm going to identify my product b plus 6. Now the b plus 6 is going to imprint on both c and 8. So writing this out, I'm going to get a product of b plus 6 on c. And then I'm going to get b plus 6 on 8. Next step, I'm going to switch the brackets around. Remember, in multiplication, order does not matter. And then remember, I don't really need the brackets if it's a singular product inside. So now, my product outside is c, and then inside it's b plus 6. And then outside here it's 8, and then that's going to imprint on b plus 6. Okay, simplifying this out, I get c, b, plus c, 6, plus 8, 6. Alright, multiplying these out, c times b is just cb, c times 6 is 6c, 8 times b is 8b, and 48. And now, because I can't do anything with this expression, I leave it at that. CB plus 6C plus 8B plus 48. Alright, let's go again. E minus 9, E plus 3. We want to expand this out. First step, we identify E minus 9 as our product. We then multiply it with E, and then we multiply it with 3. Next, we flip them around. E goes on the left, E minus 9 on the right. I drop the brackets as well. I multiply. This is going to give me E squared minus 9E plus 3E minus 3 9s, which are 27. Okay, now you might think that we're done here, but remember, when we have like terms, we're able to simplify it by summing the coefficients together. So we start off with e squared, and then we have 9e's and we add 3. We owe 9e's, but we give 3, so we're only in debt by 6e's. And then we take 27. So the rule here is that when we're expanding double brackets, we just take it slowly. We treat the first bracket like it's a product, we reverse the order of the products over here, and then we expand out for the second time. From there, we can choose to simplify if we have like terms, or we just leave it if there's nothing else to be done.